Hi, good morning. In this lecture, we are going to discuss about what is composite materials, why need of composite materials, and different types of composite materials. Uh, First, we will see the introduction. Next, classification of composite materials. Next, factors affecting properties of composites. Next, we will see the advantages and limitations. Next, difference between the smart and composite materials. Next, civil engineer applications. Next, conclusion, and finally, reference. Introduction. A composite material can be defined as the combination of two or more materials having significantly different physical and chemical properties that results in the better properties than those of individual components. The constitutions retain their identities in the composites, that is, they do not dissolve or otherwise merge compositely into each other, although they act in concrete. Composites are one of the most widely used material because of their adaptability to different situations and their relatively ease of combinations with other materials to serve specific purposes and exhibit desirable properties. The main advantage of the composite materials are their high strength, stiffness, combined with the low density when compared with the bulk materials. Next, we'll see the classification of composites. The composites are classified mainly two constitutions that are matrix and reinforcement. The reinforcement placed inside the matrix to make the matrix become stronger. The matrix may be polymer, metal, ceramic, carbon, and graphite. Polymer is further classified into thermostatic, thermosets, and thermoplastic. Metals may be alloys. Ceramics may be glass, cements, and finally will be the carbon and graphite. Next, we will see the organic the polymer matrix composites. The two main kinds of polymers are thermoset and thermoplastic. Thermoplastic may be polypropylene, polyethylene, nylon. Thermosetics may be epoxy, vinyl ester, and polyester. Thermosets have qualities such as well-bonded three-dimensional molecular structure, or after curing, they decompose instead of melting or hardening. Thermoplastics have one or two molecular structure. They tend to at an elevated temperature and so exaggerated melting point. Another advantage is that the process of softening at elevated temperatures can reverse to regain its properties during cooling. Next, you will see metal metric composites. Metal metric composites are high strength, fracture toughness, and stiffness are offered by metal metrics than those offered by their polymer counterparts. They can withstand elevated temperature in corrosive environment than polymer composites. Metal metrics are widely used in the engineering applications where the operating temperature lies in between the 250 to 70 degrees Celsius. Metal matrix are steel, aluminum, titanium, copper, magnesium, superalloys. Next, you see the ceramic metric composites. Ceramic described as the solid materials which can exhibit very strong ionic bonding in general and in few cases cold bonding. High melting points, high corrosion temperature, stability at elevated temperatures, and high corrosive strength. Ceramic matrix are widely used in engineering applications where the operating temperature lies between 800 to 1650 degrees Celsius. Next, you see the carbon and carbonate composites. CC are developed specifically for pots that mostly operate in extreme temperature ranges. Composed of carbon matrix reused with carbon yarn fabric, 3D one fabric, and 3D braiding. CC composites meet ranging from rockets to aerospace because of their ability to maintain and even increase their structural properties at extreme temperatures. Advantage of the carbon matrix composites are extremely high temperature resistance. Strength actually increases at the higher temperatures, high temperature and high strength and stiffness, good resistance to thermal shock. The graph clearly explains the temperature ranges that can withstand for the various matrix composites. Thermosets, polymer matrix can withstand temperature up to 400 to 600. For metal matrix, it can withstand up to 1000 degrees. Ceramics can withstand up to the 1200 degrees Celsius, whereas the carbon matrix compounds can withstand the temperature up to 1800 degree Celsius. Thank you.